absolute value equations look scarier than they are. Now, we understand already that absolute value means that what's inside is going to be positive no matter what. So really what we're saying is this isn't necessarily a 6. What's inside there could also be a -6. So to solve absolute value equations, what we do is we set up 2 equations. First one, we leave it exactly the way it is. 1/2 x minus 8 equals 6. And we go ahead and solve it, and we get plus 8 plus 8. 1/2 x equals 14. Then multiply both sides by 2, and I get x equals 28. But there's one other possibility. Since no matter what I put in there, whether it's positive or negative, it's going to end up being a positive. So I have another possibility for what 1/2 x minus 8 could equal. It might equal 6, or the other option, it could equal -6. Now we solve that equation in the same way. We add 8, and that gives me 2. So we have 1/2 x equals 2. Multiply both sides by 2, and I get x equals 4. Now, one mistake people do is they try to just solve it the first way and then put plus or minus, okay? But that's actually not true. Notice that this was a completely different number, and they both ended up being positive numbers. But those are our 2 answers. So here's an absolute value equation, but before we split it into 2 equations, what we're going to do is we have to get the absolute value by itself. So I'm going to start by subtracting 6, and that gives me -9 equals -3, absolute value x minus 1. Now, the absolute value is not quite by itself because we have a -3 beside it. So I'm going to divide by -3 on both sides. And when I do that, I get x minus 1 equals 3, positive 3. So x minus 1 equals positive 3. And since it's absolute value, that's going to be 2 equations. First, it could be x minus 1 equals 3. And then I could solve it and I get x equals 4. Or what could happen is it could be x minus 1 equals -3. And if I add 1 to both sides, I get x equals -2. So I end up with both of those as solutions. Solving and graphing this absolute value inequality. Now, the good news is the absolute value is already by itself. So what we're going to do is we're going to write it as 2 separate inequalities. The first one's going to be -3x plus 7 is greater than 8. Notice all I did was I erased the absolute value signs. The next thing I'm going to do is I'm going to write the same thing, -3x plus 7, except I'm going to put -8. I'm also going to flip my inequality. So because I changed the sign on the right, I'm going to flip my inequality. Now I'm going to go ahead and solve each of these. -7, -7. I'm going to do both of them at the same time to be really fancy. That gives me -3x less than -15. And this one gives me -3x is greater than 1. And so I'm going to divide both sides by -3. And again, I'm going to do both of them at the same time because that feels fancy. Notice that when I divide it by a negative, I have to flip the sign. So that's going to happen here. And I end up with those 2 inequalities. So in order to graph that, I'm going to graph each of them separately and then put the graphs together. So the first graph is going to be x is less than -1/3. So I'm going to go to -1/3, and it's less than that. That means I'm going to go to -1/3, but I'm going to go left back. This one says x is greater than 5, so I'm going to go to 5, and it's going to be greater than 5. Okay, so these are actually going in the opposite directions. So if I were going to graph them combined, what would I end up doing? Well, because it's an absolute value, and because I've got 2 of them, what this has is both of them on the same one. So I'm going to say -1/3 going this way, and 5 going this way. Now, how do we write that in interval notation? It was easy enough to write it in just inequality notation because that's what we solved it as. But in interval notation, that means we're going to write from negative infinity to positive infinity. Although it doesn't go all the way from negative infinity to positive infinity. It goes from negative infinity to negative 1/3. And then it pauses and it picks up over here at 5 to positive infinity. And in between those, since this is an or, we're going to put a u. And that's the way we're going to write that in interval notation. Here's an absolute value, and this one is a less than. I want to give you a little heads up here. When we have an absolute value and it's less than, I want you to think about it as less than, okay? So here's what that's going to look like. The first thing we're going to do is we're going to write it twice. 2x plus 8 less than equals 10, and 2x plus 8 is greater than or equal to negative 10. We change the sign and we flip it. The next thing we're going to do is subtract 8 from both sides. And that gives me 2x is less than or equal to 2. 2x is greater than or equal to negative 18. I'm going to divide by 2, divide by 2, divide by 2, divide by 2. And I get x is less than or equal to 1. And x is greater than or equal to negative 9. So I have my two graphs, but this isn't less than, this is an and. So unlike an or, where they might go apart from each other, this is actually stuck in between. This is saying that I have all the x's that are greater than negative 9 and less than 1. And so as a graph, that's going to look like greater than negative 9 and less than 1. Now I'm going to use a square bracket to show that I'm including that, but we could also use filled in circles. Last thing we have to do is write it in interval notation, and that's not too bad because we're going to use square bracket, negative 9, comma, 1 square bracket. If you have any questions, put them in the comments. Let me know.